Imagine this, you wake up tomorrow morning. The sky is bright, but suddenly social media explodes. NASA confirms a 300-meter asteroid is heading straight for Earth. You have less than 48 hours.
What happens next isn't science fiction. It's scientifically plausible.
Let's find out. Impact size 300 meters. Energy release 300 megatons. Target unknown. The science of asteroids. Definition and origin. Asteroids are rocky remnants from the formation of our solar system. 6 billion years ago, mostly found in the asteroid belt between Mars and Jupiter. Types classified by composition. Carbonaceous, C-type. Silicate, stipe. Metallic, M-type. Size matters. Asteroids over 140 are considered potentially hazardous. A 1,300-meter asteroid is categorized as a city killer. Speed and force. Most NEOs travel at 1,225 km/s. The kinetic energy scales with the square of velocity. A 300-meter asteroid could release energy equivalent to hundreds of nuclear bombs. Atmospheric entry. Smaller meteoroids burn up. But at this size, the object survives entry, causing either a surface or airburst explosion. Historical impacts. Tunguska Event, 1908. A 6-100-meter asteroid exploded mid-air over Siberia, flattening over 2,000 square kilometers of forest. Chelyabinsk, 2013, 20-meter meteor exploded with the force of 470 kilotons. Shockwave injured 1,500 people. Chicxulub crater, 66 million years ago. A 10-plus kilometer asteroid caused mass extinction, including the dinosaurs. Lesson: even small or medium-sized impacts can cause massive regional destruction. City-sized or country-level effects are entirely plausible. What if it happens today? Scenario simulation. A 300-meter asteroid approaches with 48 hours warning. Assume impact near a major city. Immediate response. Governments activate emergency protocols. Evacuations may be attempted but are limited. Impact effects. Blast radius. Up to 30-50 km completely destroyed. Thermal radiation firestorms within a 100-kilometer radius. Shockwave windows shatter hundreds of kilometers away. Seismic impact. Earthquake-like tremors. Crater size. Up to 4 km wide, hundreds of meters deep. Ocean impact. Massive tsunamis up to 100 meters high hitting coasts within hours. Airburst scenario. Could release energy at high altitude, leveling cities without a crater. Planetary defense. NASA's tools. NEO Observations Program. Identifies and tracks near-Earth objects. Sentry system predicts potential impacts up to 100 years in the future. DART mission demonstrated that we can nudge asteroids off course via kinetic impact. Other techniques: nuclear deflection, gravity tractors, laser ablation. Challenges: limited warning time. Objects coming from the sun's direction are hard to detect. Infrastructure and funding constraints. Real risk today. Current stats: over 30,000 NEOs tracked. Estimated 15,000 plus remain undetected in the 1,300 range. Probability of impact: a 300-meter asteroid has a roughly 1 in 100,000 chance per year. Statistically low but non-zero. Apophis case will pass closer than some satellites in 2029. Originally considered a potential impactor. Now ruled out, but it's a wake-up call. If we fail, global consequences. Local devastation. Millions dead or displaced. Entire cities gone. Global shockwaves, dust, and aerosols block sunlight. Impact: winter. Crop failures, temperature drop. Collapse of economies, migration, civil unrest. Long-term climate impact, depending on where it hits, could trigger years of cold famine. Massive CO2 release if it hits limestone-rich area. The future of asteroid defense. Technological hope. More space telescopes like NEO-SM, Near-Earth Object Surveyor. Artificial intelligence for early detection. Global cooperation needed. Office for Outer Space Affairs. International Asteroid Warning Network, IAWN. We are the only species with the knowledge and ability to stop an asteroid. Planetary defense is not science fiction. It's a responsibility. The question isn't if another asteroid will strike Earth. The real question is, will we be ready? Subscribe.